Session 8.5 Polar Equations and Graph. Polar coordinate system is based on a point called the pole and a weight called the polar axis. And the polar axis is usually drawn in the direction of the positive x-axis, just like this one. Polar coordinate system. Point P has a rectangular coordinate x and y. So x talking about the horizontal distance here. And then y will be the vertical distance. And we call this as a rectangular coordinate system. How about the polar coordinate system? Polar coordinate system, point P can be located by the given direction angle. This theta, we're gonna starting from the positive x-axis until the line OP here. We call this as theta. And also, we do have a direct distance r from the O to the point P. And when we write the polar coordinate system, we're going to put the r, this distance, and then the theta. That will be the polar coordinate. Polar coordinate system. If r strictly greater than 0, then point P lies on the terminal side of theta. So let's say we do have a point P, r and theta. So r talking about the distance starting from O to here. And then theta will be starting from the positive x-axis until the terminal side. This is when r strictly greater than 0. How about when r strictly less than 0? The r is a negative. What we're gonna do? We're gonna do the same thing. First, figure out the theta. Okay, starting from the positive x-axis to find out what is your theta. And then the r, when it's a negative r, that will be pointing in the opposite direction of the terminal side. So let's say this is my r theta. When we have a negative r, the line is going to be going like this way. So this line will be negative r theta. Rectangular and polar coordinate. If a point P has rectangular coordinate xy and polar coordinate r theta, then these coordinates are related as follows. So look at this triangle. When we have a cosine theta, that will be equal to adjacent over hypotenuse, which is going to be x over r. And then we're going to multiply by r for both sides. So this one cancel out. So x, that will be equal to r cosine theta. And then sine theta will be equal to opposite over hypotenuse, which is going to be y over r. Do the same thing. We're going to multiply by r for both sides. So y, that will be equal to r sine theta. Okay, right? Highlight these two formulas. X equal to r cosine theta, y equal to r sine theta. And then tangent theta will be y over x. Okay, given that x is not equal to 0. And then last one, we could use the Pythagorean theorem. R equal to square root of x squared plus y squared. Once you guys have this formula, you could convert it from rectangular to the polar coordinates or another way around. Example 1. Plot each point by hand in the polar coordinate system. Then determine the rectangular coordinates of each point. So first, we want to graph this polar coordinate. We will try to use the polar coordinate graph paper. Okay, we do have a 2 and 30 degree. So this is talking about 0, 30, 60, 90. Okay, and then 30 degree. So starting from the positive x-axis to here. Okay, And then we need 2 units. So starting from 0, 1 unit, 2 unit. Okay, so I have this one, this point that will be 2 and 30 degree. Okay, right? It'll be easier if you guys have the polar graph paper. Now we have r equal to 2 and theta equal to 30 degree. So we're gonna use the formula x equal to r cosine theta. So plug it in. What's a cosine 30 degree equal to? That will be rho 3 over 2, right? Simplify it, so x equal to rho 3. And then do the same thing for the y. Sine 30, that will be 1/2, right? So y equal to 1. And this is gonna be your rectangular coordinate. Rho 3 and then 1. Part B. Point Q, -4 and 2 pi over 3. So this is gonna be the radian. And since we need to 4 unit, so I'm gonna get another polar graph here. And this one, this is talking about 15 degree for each of them. Okay, so you're gonna know this is gonna be 0, pi over 6, and this is gonna be pi over 4, pi over 3, and this is gonna be pi over 2. 2 pi over 3, that'll be 120 degrees. So that will be this guy here, 2 pi over 3. Okay. And then 2 pi over 3 gonna be starting from positive x-axis here, go to here. Okay, this is gonna be 2 pi over 3. However, we have a -4. -4 means we're gonna go to the opposite direction. So this one, they'll be starting from here. 1 unit, 2 unit, 3 unit, 4 unit. So here. Okay, so this is gonna be point Q, -4, 2 pi over 3. Okay, it's supposed to be this line. And then opposite direction, so it's gonna be going from here. Okay, look at the picture. And then we're gonna convert the polar coordinate to rectangular coordinate. So use the same formula. R equal to -4, theta will be 2 pi over 3. You should get +2. How about the y? Outside theta, so plug it in. Sine 2 pi over 3, that will be rho 3 over 2, right? Positive rho 3 over 2. And simplify it, so that will be -2 square root 3. Okay, so that will be the rectangular coordinate for the point Q here. Okay, C. Point R, 5 and -pi over 4. -pi over 4, then you're gonna go to clockwise. Okay, 45 degree. So that will be this one. This is a -pi over 4. So you're looking for the data going clockwise. And then +5. So from this line, 1, 2, 3, 4, 5. Okay, draw the straight line. So this is gonna be your point R, 5 -pi over 4. Okay. And then use the formula. I want you guys try. Plug it in. cosine negative pi over 4 in the quadrant 4, that'll be rad 2 over 2, right? And then y equal to outside theta, plug it in. That'll be negative rad 2 over 2. Okay. So this is gonna be the rectangular coordinate. Note, while a given point in the pen can have only one pair of rectangular coordinates, these same points can have infinite number of pairs of polar coordinates. We do have a different way to write on the same polar coordinates. Look at this example. Give 3 order pairs of polar coordinates for the point P, 3 and 140 degrees. So first thing, we try to graph this point P. 140 degrees is somewhere about like here, right? Somewhere like here. And then 3 unit, I will assume this is going to be 0.5. 0.5, 1, 1.5, 2, 2.5, and 3. So this is going to be 3 here. Okay, right? 140 starting from the positive x-axis until here. And then 3 unit. So that's a 0.5, 1, 1.5, 2, 2.5, and 3. Now we're gonna find the second pairs of the polar coordinate. So I do have a positive 3 and 140 degree. First thing, I'm gonna add 180. 180 will be going to half circle. Okay, means like the opposite side of this line here. So the theta will be 140 plus 180. I want the line going to be opposite direction. So instead of using 3, I will use the negative 3. Okay, one more time. 140 plus 180. Talking about the line in the opposite way. And then I use the negative 3 instead of positive 3. So it's going to be going back to this line. Okay, so this is going to be your P1. Second one, I still have a 140 degree, right? I could use the coterminal angles. Okay, coterminal angles, I could add 360 or I could subtract the 360. So this is going to be another one. I use the same R equal to 3 and then I find out the coterminal angle 140 minus 360. Okay, the last one. For the P1, we do have a 320. It's going to be on here, right? This time, I'm going to go for the negative theta. So I'm going to do 360 minus 320. Means the line is going to be going clockwise, going like this direction. But then the line, I need to be opposite. So I'm going to do the negative 3 as well. So negative 3, 360 minus 320. This 320 is talking about the line in here. Okay, so you could see negative 40 degree. So we go back 40 degree. It's supposed to be here. And then I use negative 3. So I'm going to go for opposite side. That will be the same thing here. So 3 pairs of polar coordinates. For this point, we have this 3 more. You can make another totally different 3 from mine. Okay, you could get the coterminal angle here plus 360. Okay, or add 2 360. B. Determine 2 pairs of polar coordinates for the point with the rectangular coordinates negative 1 and 1. So first, negative 1 and 1, which quadrant is it? X is a negative, Y is a positive. So that will be quadrant 2. Okay, somewhere like here. First, we try to convert from the rectangular coordinates to polar coordinates. So we're going to use the formula. Find out the R first. Plug it in. You're going to get square root 2 here. And then tangent theta, y over x. So you should get theta will be 45 degree, right? Since the theta is in quadrant 2, so we're going to subtract from 180, which is going to be 135 degree. So we do have the first pair of the polar coordinates will be vec 2 and 135 degree. What is the second one? Second one, I'm going to do 135 degree. I'm going to plus 180 again. Okay, plus 180, the half circle. And then I'll be using the negative R. So negative vec 2. Do your math. You should get another pair will be negative vec 2 and then 315 degree. Graph of polar equation. An equation in which r and theta are the variables in polar equation. Define the polar equation of the line ax plus by equal to c as follows. So a, b, c are the real numbers. This is represent the rectangular equation. Now I want to convert it to the polar equation. Okay. So first, what is your x equal to? X equal to r cosine theta, right? Y will be equal to r sine theta. So we plug it in. And then we factor out the r. So you do have a cosine theta plus b sine theta equal to c. And then central form for the polar equation. So we're going to divide the whole things here. So r equal to c over a cosine theta plus b sine theta. Keep in mind that for the polar equation, you just want to get out all the x and y. Okay, if rectangular equation, you want to get out all of the r and the theta. Okay, try this example. Define the polar equation of the circle. X squared plus y squared equal to a squared. So this is the circle equation with the center 0, 0 and the radius is going to be equal to a, right? Okay, we want to convert it to the polar equation. So think about the four formula. These four formula, okay? X equal to r cosine, y equal to r sine, tangent, and also this one. Okay, we do have r squared equal to x squared plus y squared. Okay, so we're going to replace by the r squared. And then find out what is your r. That will be equal to plus minus a. So this is going to be the general form for the polar equation of the circle. Okay. Example 3. Y equal to x minus 3. This is going to be the straight line. So we try to convert it to the polar equation and then we want to sketch its graph. So we could rewrite it like x minus y equal to 3. And then you guys remember what is your x equal to? What is your y equal to? Plug it in. Factor out the r. And then r will be equal to 3 over cosine theta minus sine theta. So this is the polar equation. Okay, this is equivalent for your y equal to x minus 3. And then sketch its graph. I would use the y equal to x minus 3 to sketch the graph because I know this is going to be the straight line. If you want to graph it with the polar equation, then you're going to plug in the theta one by one and then calculate the r. So it will be easier if you guys using the rectangular equation. Okay, B, x squared plus y squared equal to 4. So remember, this is gonna be the circle equation, right? And then center will be 0, 0, and radius, that will be equal to 2. Okay. Now, What's the x squared plus y squared equal to? Remember the 4 formula, right? That will be equal to r squared. R squared equal to 4. Take the square root, so that will be plus minus 2. Okay, graph it. Since we don't have the data, so for every single data, r will be equal to plus minus 2. So you're gonna see you will have the circle. Okay, example 4. Graphing a polar equation. For this kind of the questions, you guys need to create a table and then try to use the degree one by one and then plug it in. Okay, I show you guys the first one. Theta equal to 0. So cosine 0, that will be equal to 1. Right? And then plug in here, 1 plus 1, r will be equal to 2. Second one, 30 degree. You could just use this calculator, okay? 30 degree, that will be 1/3 over 2, which is going to be 0.866. So I wanted to 1 decimal space, so that will be 0.9. Okay, 0.9 plus 1, that will be 1.9. Okay, strictly using your calculator, find out this table. Okay. Check your work. Now, get your polar graph paper. You're gonna do it like one by one. So first, 0 degree. 0 degree talking about here. And then my r is gonna be equal to 2. So 1, 2. So I do have the first point here. Okay. Second one, 30 degree. So this is like 30, 60, 90. So 30 degree will be here. And then the r will be 1.9. So this is 2. 1.9 is a little bit less than this one. Okay. And then 45 degree. So 45 degree will be half of this one. 45 degree and r will be 1.7. So 1.5 is here. 1.7 a little bit higher than that. And then 60 degree, that will be 1.5. 60 degree, 1.5. So half of it. And then 90 degree, so here will be equal to 1. So just like this point. Okay, right? 1, 2, 3. So you could see this is 1. Okay, keep going. 120 degree here. And then that will be 0.5. So 0.5 is going to be half of this one. 135. So like here, that will be 0.3. So close to here until you get 180. 180 degree, that will be 0. So going like here. Okay, right? You do have a half of the picture here. Okay, but you can see I only find out the data from 0 to 180, like this half circle, really details. And after that, I skip this part. I just go to like 270 and then 515 and then 530. Okay, I just graph this part as well. You should find these 3 numbers. But then think about it, since I skip all this part, I would imagine like for this picture, this is gonna be half of it. You could think about this is just like the mirror. Okay, it's gonna be copy and other half. So when I join all the points together, the picture is gonna be looks like this. Okay, if you are not sure, you could keep going. Like 180, you could do 210. You know, keep going 245, 260 or 270 and keep going one by one. you should get this picture. This curve is called a cardioid. The curve has been graphed on a polar grid, okay, cardioid. Okay, example 5, graphing a polar equation. This time we're gonna graph the rows, and then there'll be r equal to 3 cosine 2 theta. Okay, we're gonna do it like one by one. When theta equal to 0, that will be 2 times 0, which is gonna be 0. Cosine 0, that'll be equal to 1. And then 1 times 3, that'll be equal to 3. If you guys can handle it, you could just skip this part. Okay, I just need to know what is your theta and what is your r. Okay, 15 times 2, 30. Cosine 30, that will be 0.9 times 3, which is 2.6. Okay, try to use your calculator. Do it by yourself. Fill in this table. Okay, check your work. And then we're gonna use the graph paper, do it like one by one. I could show you the picture, it's gonna be looks like this. So when you're starting from 0, that's a 3, you're starting from this point. And then 15 degree, like here, you do have a 2.6. Okay, so you can see the directions going from here. 1, 2, 3, 4, 5, 6, 7, 8, and then you're done. Okay, it looks like rows. Okay, one more time, starting from 0 here. 1, 2, 3, 4, 5, 6, 7, 8, and then you're done. Okay, look at another example. This time will be r squared equal to cosine 2 theta. Okay, complete the table again. I want you guys try.
Cardioid.
Okay, check your work. You should have all those numbers. And then use the polar graph paper. You're gonna get this picture. Okay, last one. R equal to 2 theta. So I showed you guys the result here. This one, you may have a 1 or 2 homework, but I don't put it on the midterm and the final. Okay, example 7, I just let you guys know something like this, but I don't put it on the exam. Okay, so when you have R2 theta, and the theta measure in radians. Okay, so the pictures is gonna be looks like this. R equal to 2 theta. If you keep going on it, the line is gonna be extended. Okay, one more time for this one, I don't put it on the exam. Okay, I only you guys focus for like r equal to a cosine theta, r equal to a sine theta, or r squared equal to a squared sine 2 theta, or these 4 and these 4. Okay, this is something you guys may want to remember it. Okay, because when you're just looking for the equation, you're using the table, is pretty time consuming. But if you guys can remember like the form r equal to a plus minus b sine theta or b cosine theta, you compare with a and the b. If A over B is less than 1, then you may get the circles like that. Okay, but when A over B equal to 1, so you're gonna get like this part. So we do have this example, right? All right, A over B equal to 1. Okay, so we do have exactly the same thing here. A over B equal to 1. If A over B is between 1 and 2, then you could see the arc, it won't be go through the 0. Okay, this one, A over B equal to 1 is going to be on the origin here. But if A over B is in between 1 and 2, it won't be touching the origin. If A over B greater than 0, it looks like almost a circle. Okay, try to remember this form and these 4 pictures. And for the Wolf's curve, when you have the A sine or A cosine and theta, okay, n equal to 2, 3, 4, 5 or above, that's talking about the Wolf's curve. Okay, when n equal to 2, you're gonna times 2. So you do have a 2 n lifts. N equal to 2, so that'll be 4 lifts here. When n is equal to 4, you do have 8 lifts here. But when n is odd, when you have a 3 theta, so you only have a 3 lift. But when n is a 5, so you only have a 5 lifts. Okay, I need you guys try to remember the format of this picture, so you have the idea what kind of the curve we're gonna be. One more time on the exam, I only ask this one, and this one. Okay, for the last example, this guy, forget about it. That's it.